Okay, I think it's time that we start. I should have 2, 4, 6, 7 of you, but I see 5 only. So 2 of you are not in yet. I think I need to confirm the name. Gautam. Gautam, is your name Bhaskaran? Hi, Gautam, is your name?
Yes, yes.
It is, yeah? Okay, all right. So I think the rest I have, yeah, all your names, they are correct. Okay, children, yeah, some of you I've already seen before, right? And then, yeah, some were new, and then we practice writing, annotating. Yeah, so now, hopefully everybody has no more problems. So today, what we're going to do is we're moving on to fractions. So let me share my screen. Is it coming out? Okay, all right. Okay, so Teacher Bern is the one who prepared all these slides for us. So today's lesson is on what you call fractions, and what we're going to be learning today is we're going to be looking at numerators, denominators, equivalent fractions, comparing and ordering of fractions, dividing a whole number by a proper fraction, and then for word problems, we are going to be looking at the remainder concept. Now, for today's lesson, we will be trying out the branching method. Okay, I have heard feedback from students before from other years. Some people really love branching, and so in all questions they try branching. Others really hated branching, and so they avoid at all costs. Now, actually, all these are just strategies that we use. It is always a good idea for us to practice the different methods of solving, because you will find that in certain questions, right, branching may become a very, very easy way to solve, a very useful way. Whereas in some other types of questions, maybe branching becomes a little complicated. Then with a buffet of other strategies, we can actually make use of others to solve. All right. But today, some of the later questions, we will be looking at branching. All right. Kaiser, I can see you are practicing your annotation. Okay, so we start with simple questions first. So as usual, what I will do is I will ask if we have volunteers. So if we have volunteers, can you please raise your hand? Okay, Kaiser, you wrote me. Okay, Samilta Rose as well. Okay. I think all of you who have written, right? Okay, why don't you all write on your answers on this screen, and then I think I can roughly tell who is the one writing. Okay, because I can see Kaiser and Rose writing already. Samilta, you can also write your answers, and then we can actually confirm. Okay, I have some answers here already. Okay, I have 2 sets of answers already. Okay, if we haven't got any more answers, then I will just I think Samilta is writing as well. Okay, all right, good job for those people who participated. Yes, when we ask what fraction of the figure is shaded, of refers to the denominator, so the whole figure you actually needed to count. So yeah, you all have written the numbers there. There are actually 9 triangles there. And then is shaded. So the shaded part, there are only 4, appears in the numerator. Okay, so that's how we can solve this. So quite a simple question, and that is question 1. All right, so let me find my question 2 then. Okay, all right. Okay, would you all like to help me clean the, yeah, if not, then I will have to clean it myself. Okay, got it. All right. Okay, question 2. I can see Kaiser annotating already. Okay, Rose is also annotating. This is a very good idea. And I can tell why you are doing that. Okay, for Kaiser and Rose who have actually done the annotation, oh, Rose has cleaned away hers. What happens is when you do that, what you're trying to do is you're trying to make all the parts the same. So when you're making all the parts the same, it is now okay to count, right? Because everything about fraction is equal parts. So by drawing those two lines, we now have equal parts. So each square is now cut into 4 triangles. Therefore, the 3 squares, you have a total of 12 triangles. And if we're asking for what fraction of the figure, so of the whole figure, so 12 is the denominator. I can see 12 as a denominator, right? And then it's shaded. So now that we have cut them, you can count and you can see that there are 6 triangles that are shaded. Okay, so 6 triangles are shaded. Therefore, our answer is in the simplest form, half. All right, so this being a very simple question, okay, of course, yeah, we can get our answers very quickly. All right, okay, let's move on to our next question. Okay, so there we have it again. Oops, let me try to clean away, yeah. Okay, all right. Okay, now they tell you this figure is made up of equilateral triangles. Huh? Yeah, my apologies if your worksheet, your triangle doesn't look like an equilateral triangle. It should be an equilateral triangle. Okay, and then they're asking you what fraction of the figure is shaded. But I can see they are all of different sizes. Okay, I can see Kaiser and Rose actually drawing. They are cutting that 2 big triangles at the bottom to make them the same as all the other small triangles. That is a good job. Okay. If you're able to do that and you're able to cut that, then are we able to answer the question? What fraction of the figure is actually shaded? Okay, I think the rest of you are very silent. Oh, good. Okay, Lucas is writing. Okay, so we have one answer from Lucas. Kaiser, okay, Kaiser is writing the answer now. Rose is also writing the answer. I think they are trying to rush. Okay, so Kaiser, why do you clean yours away? Okay. Kaiser chose to write on the left side. Okay. I thought Samilta will participate as well, but apparently I think Samilta has stopped writing. Okay, never mind. Yes. Okay, we have 3 people with 3 answers and all 3 are correct. Well done. Because when you are able to cut your triangles like that and you are able to count, there are a total of 16 triangles of the same size. So the 16 will represent your denominator. Yeah. And then when you want to count the shaded ones, you realize that there are 10. So 10 is your numerator. So 10 out of 16, in the simplest form, it will be 5 out of 8. Okay, all right. Okay, I think we're progressing very well today. So let's move on. Okay, let me try to clean this. Okay. All right. Now, these are the type of questions that usually appear at PSLE. Yeah? So far, almost every year, one question like that comes out where they will ask you which one is actually nearest to half, which one is nearest to 2. This question is asking which one is nearest to 1. So how do you solve this? All right. Okay, I can see that Rose is writing. So let me just try to find out what Rose is doing. Okay, well done. Rose has actually worked out the gap. Okay. Lucas has put B. Kaiser has written me, but then after that stopped. And Rose is actually working on all the gaps. Right. Okay. And this kind of question, when it appears at PSLE, right, it is always if you apply the correct strategy, that means you are working out the gaps, you will find that the answer for all the options you work out, right, will all be very easy to compare. So just like in this question, right, although you have 4/5, 5/6, and then 1 and 1/4, but the gap between all these fractions and 1. So the first one, 4/5 being less than 1, you will take 1 and minus 4/5. So you end up with a gap of 1/5. The second question, part B, the fraction is 5 out of 6, which is also less than 1. So you use 1 and you minus the 5/6, and you find that the gap is 1 out of 6. You notice these are unit fractions already. One is 1/5, one is 1/6, and the third one is more than 1. So you still have to find the gap. So 1 and 1/4 minus 1 is 1/4. Therefore, the three gaps that we have, one is 1/5, one is 1/6, one is 1/4. So out of these three fractions, which gap is the smallest? All right. So obviously 1/4 is quite big, compared to 1/5, and then of course 1/6 is even smaller. So because 1/6 is the smallest, B is the answer. Okay. All right. Okay, yeah, just now we have differing answers, but I think you all have figured it out already. So yeah, so B is the answer for this question. All right, okay, now where's my pen? Now I cannot find my pen. Oh, there it has gone up there. Okay. So here we are, we have another question, and again, they are asking for comparison. So what fraction is now closest to 1/3? And how can we solve this? Okay, Samilta has written 6 out of 17. Do we have anyone else who would like to contribute your ideas and see whether 6 out of 17 is really closest to 1/3? Yeah, because when we write our answers like that, it is a little bit difficult to actually see, right? So we actually need to process and we need to calculate. Okay, I can see Rose working on the 6 out of 13 in A. And what she's doing is she's multiplying by 3 out of 3. And then 1/3, she's going to multiply by 13 out of 13. So she's actually she's actually going to make the two denominators the same. And therefore, with the denominators the same, she will be able to actually subtract. So Rose is actually working on the gap. All right, Samilta has already given the answer, so we don't know what was the strategy used. But if you can see what Rose is doing, she's working on the gap. So based on the gap, right, the gap between fraction A and 1/3, the gap is 5 out of 39. Okay, Kaiser is also working on the gap. You can see once they apply this method, right, they're actually working on the gap. So they are making the denominators the same. So 15 this time. Okay, and she ends up with 6 out of 15 minus 5 out of 15. So the gap now is 1 out of 15. Okay, so Milton says guess and check. All right, okay. Rose is writing 2/5. Okay, that means it's B. She's doing the same one as what Kaiser has done. So she gets 1 out of 15 as well. Okay, this one, when we work on the gap, it looks a little hard to compare, right? Because one, the gap turns out to be 5 out of 39. The other one, the gap turns out to be 1 out of 15. And I can see Kaiser and Rose, both of them are working on the third one, which is 6 out of 17. Okay, yeah, both of them are writing. So you all may want to see how, yeah. So one is 2 times 3, the other one times 17, right? So the denominator will be the same. Okay, then you get 18 out of 48 minus, okay, let's see. Kaiser seems to have stopped. Kaiser is writing on the opposite side. 18 out of 51. Yes. So Rose, be very careful. 17 times